Welcome to Nimu's World. It's me Nimesh Naik. Today I am discussing CSIR net questions December 2018. Topic real analysis. It's a part B question. Question: let a of n is equal to integral over n to n plus 1 1 by x power 3 dx for n greater than or equal to 1. For c belongs to R, let a limit tending to infinity n power c a of n is equal to L. Then option number 1, L is equal to 0 if c greater than 3, and option number 2, L is equal to 1 if c is equal to 3, and option number 3, L is equal to 2 if c equal to 3, and option number 4, L is equal to infinity if 0 less than c less than 3. So in this question, first we want to find a of n, then we want to find the limit tending to infinity n power c a of n for the following cases. So first, a of n is equal to given integral over n to n plus 1 1 by x cube dx. So which is equal to, by integration we get x power minus 3 plus 1 divided by minus 3 plus 1 within the limit n to n plus 1. So which is equal to minus 1 by 2x square within the range n to n plus 1, because x power minus 3 plus 1 which is equal to x power minus 2 divided by minus 2. So which implies that minus 1 by 2x square. Now 1 by 2 take it outside, it's a constant, so take it outside, minus 1 by 2 into, then we applying the limit, become 1 by n plus 1 all square minus 1 by n square. So which is equal to minus 1 by 2 into, then we are rearranging this, so we get n square minus n plus 1 all square divided by n square into n plus 1 all square. So while expanding, and we get n square, this term, while expanding this term n plus 1 all square, we get n square plus 2n plus 1, then we get this which is equal to minus 1 by 2 minus 2n plus minus 2n minus 1, then taking a minus common outside, then we get minus of 2n plus 1, then divided by n square into n plus 1 all square. Then from this we are taking n common, so we get 1 by 2 into n into 2 plus 1 by n, then the n square is there, then we are taking n common outside from n plus 1 all square, so we get n power 4 into 1 plus 1 by n all square. So this term will become 1 by 2 n into 2 plus 1 by n divided by n power 4 into 1 plus 1 by n all square, which is equal to, on simplification, n and over 1 power are cancelled, so which is equal to 1 by 2 into 2 plus 1 by n divided by n power 3 into 1 plus 1 by n all square. Now we want to find n power c a of n. So here n power c into a of n, substituting the value of a of n here, so we get which is equal to 1 by 2 into n power c into 2 plus 1 by n divided by n power 3 into 1 plus 1 by n all square. So n power c into a of n, which is equal to 1 by 2 into n power c minus 3 into 2 plus 1 by n divided by 1 plus 1 by n all square. Now if we put c is equal to 3, then find the limit, then limit n tending to infinity n power c into a of n, which is equal to limit n tending to infinity 1 by 2 into n power 3 minus 3 into 2 plus 1 by n all divided by 1 plus 1 by n all square. Then n power 3 minus 3, which is equal to n power 0, so n power 0, if this term will become 1, as n tending to infinity 1 by n approaches to 0, and here also 1 by n approaches to 0, so this term will become 1 by 2 into 2 plus 0 divided by 1 plus 0 all square. So this will be, which is equal to 1 by 2 into 2, which is equal to 1. So when we put the value c is equal to 3, then limit n tending to infinity n power c a of n, which is equal to 1. So our second option, which says that L is equal to 1 if c is equal to 3, and our third option says that L is equal to 2 if c is equal to 3. So from this we get, when c is equal to 3, L is equal to 1. We get the value L is equal to 1. So our option number 2 is correct and option number 3 is false. Now if we are suppose that is C greater than 3, C greater than 3 means C minus 3 is equal to some positive quantity. So I take him C minus 3 is equal to K, because C is greater than 3, so C is greater value, so C minus 3 is equal to a positive term, so I here choose C minus 3 is equal to K. Then limit n tending into infinity n power C into a of n, which is equal to limit n tending to infinity 1 by 2 into here n power C minus 3, and when C greater than 3, and C minus 3 is a positive term, so which will be replaced by some K, so which is equal to 1 by 2 into n power K into 2 plus 1 by n whole divided by 1 plus 1 by n all square. So as n tending to infinity, this whole term will be approaches to infinity. Now if C less than 3, that implies that is C minus 3, which is a negative quantity, so it will become some minus K. So limit n tending to infinity n power C a of n, which is equal to limit n tending to infinity 1 by 2 into n power minus K, that is n power C minus 3, and C minus 3 is equal to some minus K, so n power minus K will become 1 by n power K into 2 plus 1 by n divided by 1 plus 1 by n all square. Then as n tending to infinity, this will approaches to 0, this will approaches to 0, and also this will be approaches to 0, then the whole term will be approaches to 0. So when C less than 3, this limit n tending to infinity n power C a of n will be approaches to 0. Now we are going through the options. Our first option is says that L is equal to 0 if C greater than 0. So when C greater than L is equal to 0 if C greater than 3. When C greater than 3, we will get this term, this limit will be approaches to infinity. So here we L is equal to 0, so our first option is wrong, and L is equal to infinity if 0 less than C less than 3, our fourth option. But we get this limit L is equal to infinity only when C greater than 3. So our fourth option is also wrong. So the correct option of this question is option number 2, and that is L is equal to 1 if C is equal to 3. Okay, thank you. If you like my video, please subscribe my channel and also share and like.